Hello, welcome to IGCSE at Maths Topical Solution Series. In this video, we're going to look at the topic of series, or sometimes it's called progression. We're going to pick one question which is taken from March 2020, paper 2. Let's hop into the questions. It takes up 2 pages. Okay, let's start. It is from question 13, part A. Let's read the question. The sum of the first two terms of a geometric progression is 10 and the third term is 9. Part 1. Find the possible values of the common ratio and the first term. Okay, as we approach the questions, as I mentioned, it is always helpful to us as we read the questions. We pay attention in the language that is presented before us, and as we read through them, we try to coin them into the symbol that is related in the formula. Okay, as we have noted here, I've presented the two statements in two respective colors. The green statement tells us the sum of the first two terms. The sum of the first two terms, and they also mention to us geometric progression. Well, we just go on, flip to the formula sheet on the second page at the exam papers. Comfortably, we go to draw out the formula that is related to this statement, which is the sum of the two terms. Okay, so when we get that, the n we know that is 2, then we take this formula. We just do all the substitution accordingly. Well, when a, the bracket 1 minus r, the n is 2, so just substitute that over 1 minus r and equal to 10 because it is given to us the 10 as the sum of the first two terms. From there, what we do onwards from here is we will rearrange and simplify in order to form a simplified statement. Okay, what I've done in the simplification, I notice of the 1 minus r, and we know that from the basic algebra, we know that this is the difference of two squares, that we can break this two term down into this 1 minus r multiplied 1 plus r. As we break this two down, then now we can comfortably cancel out the 1 minus r, and we simplified into a bracket 1 plus r equals to 10. Let's leave that statement aside, and we hop on to the second statement given to us. The third term is 9. Well, let's go on. The third term, geometric progression. Again, go to the formula sheet, draw out the related formula. Here I presented to all of us here. U of n equals to a r n minus 1. Okay, for the third term, then we know that n equals to 3. We do all the substitution accordingly when n equals to 3. And simplified, we get into this statement. Now, the next thing, we know that we're going to solve simultaneous equations. Why? Because we know that the instruction, or rather the mission that we wanted to achieve, is to find two values. The first value is to find common ratio. The second value is to find the first term. Therefore, we're going to draw, or from this information, coin them into two statements, which is the two equations, and using all the relevant method, we're trying to do the elimination and then find one of the value, then use that one value to find the others, as we have learned previously in solving simultaneous equation. Well, without further ado, let's move on. I have copied over the first statement, the green one, and then the second statement, which is the second one. And then from here, as we look the statement that we can using the substitution, let's put in the A, which is the 2, into the A here. Say where we got here, 9 over r square bracket 1 plus r equals to 10. We just substitute this into this. And then from here onwards, do the same thing. We will try to rearrange, and then we will try to simplify and to solve for r. Because by the substitution just now, 2 in 1, we have eliminated a. Now we go on from here. Okay, let's cross multiply. Multiply the r square across. This is what we get. Then from here, we expand the bracket in order to get this statement, 9 plus 9r. Then what we do, we're just going to form a quadratic equation and equate them to 0. Therefore, we move all the components over to one side. Then we have formed a quadratic equation. And from there, we get the two respective factors. Then from here, we take turns to solve each factor to equal 0. We get the first r as 3 over 2, and the second r, we get it as minus 3 over 5. And as the questions ask for, the possible values of common ratio. There you go. You have got the two possible values, which is r, possibly be 3 over 2 and minus 3 over 5. Then the next statement, the first term. In other words, we're going to find a, because we know the definition of a in the formula is the first term. Okay, we are going to use the substitution. Let's take the r equals to 3 over 2, substitute into any of the equation. You can sub into equation 1, you can sub into equation 2. For this solution, I just randomly sub into equation 1. And by substituting that, and we comfortably get a equals to 4. And we take turns when r equals to negative 3 over 5, sub into 1 also, we get 25. There you go. We have managed to secure the 5 marks for part 1. Okay, we move on to part 2. Let's read the question. Find the sum to infinity of the convergent progressions. Again, still sure, sum to infinity, we go to the formula sheet at page 2, draw out the formula printed there, and I have drawn it out and I paste it here showing to us, and we are going to take the two possible r value, put in and sub into the sum of infinity. Okay, so when we got that, and then we got the two answer, sum to infinity, which is negative 8. And then the other one, when we sub r equals to negative 3 over 5 and a equals to 25, accordingly, we get this answer. Okay, now before we conclude, we know that this question is asking for convergent progression. In other words, I put down here a little notes. Okay, for a geometry to converge, the condition is the r has to be between positive 1 and negative 1, and the r has got to be positive. Okay, so therefore, what we're going to do is, yes, so we know that as a convergent progression, the sum to infinity, the sum to infinity, as I put down here, the sum infinity, that they can draw as close as they are towards 0, and we carefully note that it is impossible to be a negative value. So with that reasoning, we discard this value and conclude only to this. So you can present your answer and is acceptable by the mark scheme as improper fraction, as a mixed number, or even as a decimal point. Well, that's the end of A2. We move on to the next page, part B. In an arithmetic progression, given to us U1, which is first term, equals -10, and U4, which is also the fourth term, equals to 14. Then they give us the instruction to find U of the 100 terms, adding on all the way to U of the 200. The sum of the 100 to the 200th term of the progression. Okay, now, as usual, before we can progress, we know in order to find the sum, we need to know the two basic value, which is the A, the first term, and also the common difference for this arithmetic. Therefore, without any delay, what we do is we will use these two information, convert them into the formula, substitute them accordingly. The first term, which is also A, which is equals to -10, and the fourth term, we know from the formula, substitute n equals to 4 and equate it to 14 and simplify all the way, then you know and you get D equals to 8. Now, from next step, what we're going to do is to find the sum of the 100 to 200 term. Okay, in this solution, I will present to you 3 different methods that you can compare among them, and then you can decide which is the one that works best for you. Okay, this is the first method. Let's begin. For the first method, what we do is we take from the formula sheet the formula of the sum, and we use the first version, which is half n bracket a plus l, where a is the first term, l is the last term. Well, from the question it was given to us, the first term in this summation, the first term is the 100th term, and then the last term is the term of the 200. Therefore, what we can do is we can use the nth term given from the formula. If you haven't memorized it by heart, do not worry. You can still draw that from the formula sheet, and you're going to take that, and then you have known the A from the previous part, where A was given to you as -10, and you have found the D as 8. Do the substitution accordingly. When finding the first term in this case is 100th term, so you go ahead to find the 100th term. Substitute that, and n equals to 100, and 100 minus 1, multiply the D, and you get the first term, or the 100th term, is 782. And the last term in this summation is the 200th term. Therefore, let's go to find the 200th term. The same way, use the same formula, A plus n. Now n is 200 minus 1, multiply the common difference, and you get that as 1582. Okay, now the next, in order to use this formula, you have known the 100 term, you have known the 200 term, you need to know the n. How many terms are there in between, from including the 100 all the way to the 200th term? Okay, in order to find the total number of terms, we know that we're going to take the ordinal number, which is the 200 minus the 100 plus 1. And we know that it is altogether 101 term. Therefore, n in this case is 101 term. Well, I put an asterisk here just in case you have the question, why do we plus 1? Okay, let's go to the next page and I will break it down to you. I'm putting a very simple example here. I've listed here. There are boxes, and altogether we know we have counted. If it says how many boxes are there, okay, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 boxes. And when we say 8 boxes, what do we mean by that 8 boxes? Well, let's go and take a look. There are 2 types of numbers in mathematics. The first one, we call them cardinal numbers, which we define here, the numbers that tell the quantity of something. And that is the number 8, the 8 boxes, the one that I've just used just now, 8 boxes. To answer the question, how many boxes are there? The 8, this is cardinal number or counting number, telling you that there are 8 boxes altogether in quantity. And there is another type of number, we call them ordinal numbers. What are they? They are actually numbers that tell the position or the order of something. In other words, in this example, I put out here, the second box has a star on it. Well, as I have drawn here, well, the second box. So it is not 2 boxes, but it is the box number 2 in the order, second one. All right, so that is called ordinal number. Now, come to the point of our interest. Finding from ordinal number to cardinal number. Because the question just now, we know that from 100 to 200, we wanted to know how many terms altogether are there. We will use a very simple example here. If I were to ask how many boxes are there from the 3rd box to the 7th box? Well, how many? What are the quantity between starting from the 3rd box to the 7th box? Then we know if we manually counting, we know that we're going to start counting from here. Okay, and we will end counting from here. And let's do the simple counting. 1 box, 2 boxes, 3 boxes, 4 boxes, 5 boxes. So we know that from the 3rd box to the 7th box is actually not 4 boxes. It is not 7 minus 3, but in fact, it is 7 minus 3. We need to plus 1 in order to make up the correct counting number. Therefore, the numbers of quantity of boxes, okay, from the 3rd box to 7th box is actually, we will take the 7th minus 3 and we're going to plus 1 in order to converting the ordinal number to cardinal number. Okay, with this background, we will continue our solutions from here. Okay, for that reasons, from the ordinal number of 200 minus 100, we know that we get 100, and we're going to plus 1. That's to make up the total terms is 101. Now we have got all the information we need. We have A, we have D, and we have N. Now we just take from this formula, half, we're going to half times N, 101. Then bracket the first term in this case, which is the 100th term, 782, plus the last term in this summation, which is the term 200, and therefore we get 119,382. This is first method. Okay, let's go on and take a look at second method. Here we go. Second method. How do we approach this question? The second method, we also use the formula given to us from the formula sheet, but not using this version. We are going to use this version. Okay, now what do we do is, again, we take and consider the 100th term as the first term. Okay, so now what we do is we're going to use the 100th term. We're going to find it and going to substitute into that A in the formula. And then here we go. Find the 100th term. We use the nth term, the one that we have familiarly using, the same formula here. We substitute with n equals to 100 and d as 8, because that is the common difference we have found in part 1. And again, using the same reasoning that we did to find how many terms between the 100 to the 200, the reasoning that we used just now, and that we know it is n equals 110. And therefore, by substituting into them accordingly, so we got now the A is the 100 term, and that's how we substitute that. And then the number of term is 101. 101, substituting accordingly. And again, we comfortably obtained the same answer, which is 119,382. Now, we're going to go to the third method for your consideration. Well, the third method is, it will be easy if you were to look at this drawing or this diagram. We actually using this perspective. In order to get the sum of the 100 to 200, we can actually take the sum of the first 200 all the way, from the first term all the way to the 200, minus the sum of the first all the way to the 99. That is what we have. So the sum of the first 200 term minus the sum of the 99 term. Well, we will use the formula that was given to us, this portion, and find the sum of the first 200. And then from here, we know, for this case, we will know that the number of the first 200, and we can comfortably know that n is 200. For this case, we do not have to worry about, do I need to plus 1 from ordinal to cardinal? No, this one you just start from the first all the way to 200. So your n is 200 for the sum of the first 200, and your n is 99. Your n is 99 for the sum of the first 99 term, and you do the substitution accordingly into this formula. There you go. The sum of the first 200, you got 157,200. And then all the way here, this is 157,200. And then the sum up to here, the first 99 terms, you got them as 37,880. And by cutting out from the total and cut out this portion, and that's how you get the 100 from the term 100 to 200 by putting in the sum of the 200 minus the sum of the 99. And again, you notice that you managed to get the same answer, which is 119,382. Okay, so that's the end of this question for your review. Okay, take your time, digest over the video. If you need to, repeat them and just acquire all the reasoning and the thinking. In short, I would recommend you to know that usually what helps us in solving series questions is just as we read through the questions, carefully noted their information and gently translate them into the mathematical formula or statement. And then it is quite often, a lot of time, we will need to use the skill of solving simultaneous equation. Therefore, if you find you're not so sure about solving simultaneous equation, you may look into the practices of handling them, and I'm sure you were able to handle the series or progression questions confidently. Okay, so very, very soon, I'm going to make another video on the same topic, but from another questions. Looking forward to see you in the next video and wishing you happy learning and all success to you. Bye-bye.